What's up, Beloved Physics fam? Today we're going to be looking at ballistic pendulums. Let's get into it.
Slow your roll, Donald. They have yet to like and sub. Now we can get into some physics.
So in this type of ballistic pendulum problem, we have a block suspended by a string, which gets a bullet fired at it with mass of 0.5 kilograms or 50 grams. The length of the string and the angle of the string is both given, and all we have to do is determine the initial velocity of the bullet. Here are a couple images that can help explain this situation, in which this is the before the block is struck by the bullet, this being the bullet of course, and then this is where they are both together just being hit, and this is the third step in which they reach their maximum height. From this to here can be classified as h, in which we will later find. Sometimes h can be given in a problem, but in this case it isn't, so we must take an extra step to find h from the length and the angle that it swings at. This question can be simplified by a couple steps in which we can find the gravitational energy here, then use it to find the kinetic energy and when they're going together, and then using momentum to find the original velocity of this bullet. Here is more of a physics representation showing like the length of the string here suspending the block and the bullet. The length then switches to being the hypotenuse of this triangle. And the height happens to be the difference of like the end of the string. So the bullet will then travel with the block up here. If we can find this difference, if we can subtract this side of the triangle from L, we are able to find the height. So using that, we can then move on to the 5 steps that we can take to then find the initial velocity of the bullet. So starting with finding h, which is this, from taking this side of the triangle and subtracting this side, like subtracting L by this side. So we can find that by taking L and then subtracting L cos theta, being the adjacent side. We can use that to find this length. Subtracting would give us height. With height, we can then find gravitational energy, which is the mass, the total mass. So we must use the mass of both bullet plus pendulum, a gravity, which is 9.8, and height, which is going to be found. Then using that, we can assume that the gravitational energy here is equal to the kinetic energy, because it is, because in this one energy is transferred from all kinetic to gravitational. Then we can find the V2 of the bullet, V2 of the bullet plus the pendulum, because down here they're moving together. So from EK2, which is 1/2 mass total, and V kind of total because they're together. So we can use that. We can isolate V from this to find the velocity of the bullet plus the pendulum. In our 5th step, we can use the momentum of the initial bullet and make it equal to the momentum of the bullet plus pendulum, which is true because the initially the pendulum is at rest, and when you add the bullet and when it hits it, they move together, so that the momentum from the bullet is translated into adding for both of them. And then we can use the formula which I've written down, which is mass of bullet and velocity of bullet. So mass and velocity of just the bullet is equal to the mass, the total mass and the total velocity after the bullet makes contact. To find h, we must first take L minus L cos theta, which is going to be L equals the length of the string was 2.5 meters. I'm not sure why it says ml. It is meters. I will choose that right. Meters minus cos 30 degrees. Okay. Which equals 0.3334936. So this was 1. So we have that. Now let's move on to 2, which is finding the gravitational energy from that. So let's use the formula E G equals mass. So we must add the both mass of the bullet. I'm just write tote. Gravity, which is 9.8 meters per second, and then height, which we have found here. This will then make our equation. I'm just going to add the masses together. After using the calculator, I did realize that this was not necessary because this was probably one of the easiest math problems that will come up in this class. It was literally simple addition, but that's alright. 9.8, and then the height is this number, so we can plug that in down here. This puts us at our gravitational energy at 6.7288642 joules. So we can then use that, which is going to equal our EK value. So then our kinetic energy is equal to 1/2 the total mass, so bullet plus pendulum, velocity squared. Now, we do not know velocity, which is what we're trying to find, so we must isolate this. This then turns this equation into all square rooted, 2 times 2, because when you divide by 1/2 and you multiply by 2, so it's 2 multiplied by the gravitational energy divided by the total mass, all under square root, since velocity is square. This then shows the velocity of the block and the bullet together being 2.56217595 for the velocity. This is in meters per second. So we can then use this together. So now we are on step 5. We can use the speed to find the momentum of the bullet by itself. Here is the final step that we're going to do. So we've made the momentum. This is the momentum formula here, where the momentum of the original bullet, this together is momentum. The momentum of the original bullet is equal to the momentum of the total bullet plus pendulum momentum. The block is at rest, has no momentum, and when the bullet hits it, they join momentum since they then connect, right? We can then extract VB1, so initial bullet velocity. I've just put all the given, like, known variables on one side and just isolated the unknown, which is what we're trying to find in this whole question here. We're determining the initial velocity. From here, we can then sub in the numbers. Here I've subbed in each variable here. So we have total mass, which is from the one block, again from the one block plus the bullet, and the V2 here, which is the total V2. I wrote V2, but it's just the velocity of the second situation, so it is V2. And in this case, it would be the block plus the bullet, since in the second event they are together and they move together. And then I divide that by the mass of the bullet. So now we can solve this equation in our calculators to find the velocity. Here's what I got after doing the calculation. Now this number is very large, 105 meters per second. But that is understandable because we are looking at a bullet here, which generally does travel quite fast. Then we can use sig digs to give our therefore statement. So here I've used the sig digs. In this case, we have one sig dig is the lowest, so we must use that as our indicator of our answer. And I've wrote the bullet's initial velocity is roughly, with this dot, 100 meters per second. So we have now figured out the question that's been asked, going through the steps of how we can solve it. We've used a diagram to understand it. and we've included all the physics representations, the sketch, and that is how you can ace the ballistics pendulum problem in the next test.